Okay, these are the 5.4 part 3 notes, and we're going to be looking at solving logarithmic equations. All right, so solving a logarithmic equation. First thing that you're going to want to really do is you're really going to make sure you understand rewriting logarithms. If we're still kind of confused on how to rewrite logarithms, make sure you're coming to see me and talking with me. Make sure we're looking at that 5.4 part 1 information and we understand the inverse of an exponential and how we write this out. That's how we're going to solve a lot of these basic logarithmic equations. We'll move from there, but right now I'm going to rewrite this as 3 squared is equal to 4x minus 7. All I've done there is rewrite the logarithm. I know that a logarithm, if you have a logarithm base, it's the base of your exponential. What your logarithm is equal to is the exponent of your exponential, and then what the logarithm is of is what that exponential equation is equal to. So all I did was rewrite this as an exponential, and from there I've got a really easy equation to solve. 9 is equal to 4x minus 7. I add 7 to both sides. I get 16 is equal to 4x. Divide both sides by 4, and you will find that x is equal to 4. And there's your answer. It is as simple as that. All right, let's move on to the next one. Log base x of 64 is equal to 2. So again, I'm going to see that x squared is equal to 64. I just rewrite this as an exponential equation. Easy stuff. Now that I'm here, I go through, I say x is equal to the square root of 64, and I get x is equal to 8. Now some of you recall that, like in Algebra 2 and other places, it is drilled that x squared is equal to 64, and when you take the square root of this, you're taking the square root of positive negative 64. Well, we don't need to worry about this with logarithms. This is not something that we have to concern ourselves with. Remember, one of the rules for logarithms is that a must be greater than 0, and a cannot be equal to 1. So in this case, since a has to be greater than or equal to 0, that means we only have to solve for the positive square root. I don't have to consider that negative number either. If you tell me it's positive negative 8, then I have to take points off because that is incorrect. It can't be either of those. It can only be the positive number because in a logarithm, your base a has to be a positive number. All right, now using logarithms to solve exponential equations. Now, we've kind of worked frontwards where I've taken a logarithm and turned it into an exponential. Now we're going to work backwards. I'm going to take an exponential, I'm going to turn it into a logarithm. So when I look at this, I'm going to say that the natural logarithm of 5 is equal to 2x. Now, how did I get there? You might be a little confused. What we have to remember is that the log base of e is equal to the natural logarithm. So what I've actually done is I've said that the log base e of 5 is equal to 2x. Now the log base e, that the base of that exponential is e, so it's log base e. The exponent is 2x, so the entire logarithm is equal to 2x, and then what my exponential is equal to is 5, so I'm taking the logarithm of that. Now you might be asking, why are we writing natural logarithm? Recall from the 5.4 part 2 notes that we learned that the natural logarithm is the logarithm specifically for the number e. And if we write log base e, I'm going to have to take points off because, again, even though it's technically correct, it's not absolutely correct. We want to make sure we are specific with our language and we know exactly what we're doing. Once we're here, we're actually going to have to use our calculator. So the calculator section is a big part of exponentials and logarithms. I'm going to go ahead and say that the natural logarithm of 5 divided by 2 is equal to x. And then I'm just going to plug in the entirety of the natural logarithm of 5 divided by 2 is equal to x. This is because our calculator is going to give us decimals. You're going to have to give me a rounded answer. And I want to make sure that when you give me a rounded answer, it's as specific as possible. The longer and longer you wait to plug it in your calculator, the better and better your answer gets. If you take the natural logarithm of 5 and divide it by 2, it's going to be pretty close to the actual answer. But if you rounded the natural logarithm of 5 divided by 2, you're going to be off by like 1/100th. And then 1/100th is not a big of a deal, but when you start plugging in logarithm after logarithm after logarithm, and when we get to multi-step equations in 5.5, 5.6, those roundings can be way off, and that can give you a wrong answer. So if you wait till the end to plug it on your calculator, it helps. Here, when you plug this in on your calculator, you're going to get x is equal to 0.804718956 Normally, I want you rounding to about 3 decimal places at the end. So x is equal to 0.805. We'll round there. That's my answer. All right, as I stated earlier, exponentials can be used a lot in applications, so we're going to look at an application right now. The blood alcohol concentration is the amount of alcohol in a person's bloodstream. A blood alcohol concentration of 0.04% means that a person has 4 parts alcohol per 10,000 parts blood in the body. Relative risk is defined as the likelihood of one event occurring divided by the likelihood of a second event occurring. For example, if an individual with a blood alcohol content of 0.02% is 1.4 times as likely to have a car accident as an individual that has not been drinking, the relative risk of an accident with a blood alcohol content of 0.02 is 1.4. Recent medical research suggests that the relative risk R of having an accident while driving a car can be modeled by the equation R is equal to e to the k times x power, where x is the percent concentration of alcohol in the bloodstream and k is a constant. All right, so all this is giving us the equation. Don't worry too much about the paragraph there. All we needed to find out was the equation. Part A. Medical research indicates that the relative risk of a person having an accident with a blood alcohol content of 0.02 is 1.4. Find the constant k in the equation. So I'm going to set this up as the equation. We've learned that R is the relative risk, and we know that our relative risk is 1.4. We know that X is equal to the blood alcohol content, and the blood alcohol content is 0.02. So I'm going to say that 1.4 is equal to e to the 0.02 times k. All right, so now I can go ahead and start solving this. The natural logarithm of 1.4 is equal to 0.02 times k. So then that means that k is equal to the natural logarithm of 1.4 divided by 0.02. So I'm going to go ahead and plug this in on my calculator. Natural logarithm of 1.4 divided by 0.02, and that is equal, k is equal to 16.824. So now I'm going to go ahead and use this k value for all other parts of my equation. I'm going to consistently use this k. So basically I can rewrite this equation now as R is equal to e to the 16.824 times x, or that blood alcohol concentration. All right, so if this is the value of k, what is the relative risk? If the concentration is 0.17%, so now I can say that R is equal to e to the 0.17 times 16.824. So I'm going to put e in on my calculator, and just so we're aware where the buttons are, if you go all the way to your left-hand side in that second alpha column and the on column, it's 2 buttons above the on button. You'll see that ln, that is the natural logarithm. And then e to the x, you have to hit second, and then you're going to hit your natural logarithm button, or the ln button, and then that gives you e. And then from there, you can go ahead and plug in e to the 0.17 times 16.824, and we will find that this is 17.463 times as likely. So the relative risk is 17.463 times as likely to get in an accident. And that one's just nice because it's just plug and chug. We already know the equation. We can go from there. All right, so now we're going to keep using this value of k. What blood alcohol concentration corresponds to a relative risk of 100? So I say that 100 is equal to e to the x times 16.824. And I go ahead and I say the natural logarithm of 100 is equal to 16.824x. I divide by 16.824. And I get that this is x is equal to 0.274 So this is a 0.274% BAC, or blood alcohol concentration. All right, if the law asserts that anyone with a relative risk of 5 or more should not be having driving privileges, at what concentration of alcohol in the bloodstream should a driver be arrested and charged with a DUI? All right, so here, it's the exact same thing as we did up there. We're saying 5 is equal to e to the x times 16.824, and then it's the exact same method of solving as we did prior. So this is the natural logarithm of 5 is equal to 16.824x. Divide both sides by 16.824. Go ahead, do your division, plug it in your calculator. And we find that x is equal to 0.096% BAC. Now, you might be saying, Mr. Yehlen, the legal limit is 0.08, and the law assert, why is it not 0.096? Well, if it's 0.096 is 5 times as likely to be in an accident, I'm going to go ahead and say that if the government is making it so that you can't have as much alcohol in your blood as 5 times the risk is, you can only have a little bit less than that. Perfectly fine with them setting that limit to be a little bit lower to make sure that people aren't getting in an accident while they're driving. It's one of those things where it doesn't have to be exactly equal. I think a little bit of a less than is a good thing. And you'll see like how quickly all of these make sense, where if you've got 0.17, you're 17.463 times as likely, and if you're at 0.274, which is above 3 times the legal limit, you're 100 times as likely to get in an accident. So all of these make sense. As your blood alcohol concentration goes up, your risk of getting in an accident gets higher. Everything here adds up. So I have just a quick check for how correct I am. And the biggest thing that I want to make sure is that my relative risk is going up as my blood alcohol concentration is going up, and I see in fact that it is. All right, you guys have a homework assignment tonight. If you have any questions or concerns, please reach out as soon as possible, and have a great night.